According to the original IBM announcement letter from 1992, this PS2 Model 57 SLC offered up to 88% performance improvements over the previous 386 SX. This machine has an IBM 386 SLC with 8K of level 1 cache running at 20 MHz. In this video we're going to restore it and try to improve the performance even more by repairing and trying out the CPU upgrade board. This IBM is huge. There is one machine that is wider, but I think this might be the tallest PS2 desktop. Someone has tried to pry the cover open with a screwdriver here, so it has some ugly marks, and overall this case is a bit bent. Another thing is a bit skewed. So unfortunately I think someone has dropped this machine. The screws at the back are missing, so we can just pull that case off. The two tabs for the screws at the back are both broken off, so I'm pretty sure it has been dropped. There is actually something interesting with this case. Yeah, something is going on with this badge here. Yeah, look at this. It can be turned 90 degrees. So that means this desktop here can be used as a tower instead. Let's take a look underneath. Yeah, it has a plastic cover underneath to look reasonably good standing up like this. Although it would need some cleaning first. And apparently two of the rubber feet are missing. I think the front panel is removable by pushing on this latch here. Yeah, that was a pretty good guess. But I have restored a similar machine. This front grille here is covered by a plastic piece. So apparently IBM didn't want the airflow to go through here. Same thing with this grille here. Okay, so now this piece here seems to be loose too. But it's stuck in some cables. And I think there's a speaker behind here. So quite toolless so far. And up here we have a hard drive that can be removed by pushing on a tab. And in here we have a 200 meg IBM branded SCSI drive. So probably the original drive. I'll check the specs later. If we zoom in on the diskette drive, we'll see something interesting here on the eject button. This is a 2.88 meg drive. One of relatively few IBM inventions that never took on. But luckily these drives will take regular diskettes too. And it comes out together with the cage. And apparently these quirky drives were made by Sony. So perhaps I shouldn't call it IBM's invention, but at least they're trying to standardize it. And down here we have rails for a second drive. Unfortunately, someone seems to have snatched 4 of the cards from this machine. And apparently he kept one of the screws too. So that was a bit stingy. Aside from the usual PS2 serial parallel and VGA, this machine also has external SCSI at the back. And a plastic cover to make the machine look good from the back. We have seen a similar cover in another machine. I think it was the 350. So if I remember correctly, we need to push on this tab here. It also has tabs tucked in this corner here. And a third tab down here. And now the cover comes off. With that cover removed, we now have access to a rather beefy power supply made by AMTECH. Okay, so with 4 screws removed, it slides out through the back. So let's disconnect it from the motherboard. Definitely not AT standard. Let's pull that power supply out. And it has a second connector to the motherboard with much smaller wires. Very odd shape. So definitely not a standard power supply. Inside the machine I found a broken off piece of plastic and one of the missing screws from the back. With the power supply out, we can now disconnect this cable here. That goes to the front panel. So the front panel now popped out. Inside the front panel we have a speaker, a couple of LEDs and a power switch. That is unfortunately white. And we're also getting some nasty dust bunnies coming out of this machine. So we're gonna go for a complete disassembly. So I can wash everything and leave it to dry while we fix that interposer card. Next up is the riser. It's installed with rivets to this thick metal bracket here that also has a couple of screws at the back. So I think we can pull the riser out now. The riser also has a coin cell for the clock. The rail for full-length cards seems to be attached with a screw inside here. And the last part to come out is the motherboard. A surprisingly small motherboard for a large case like this. I guess they wanted to make room for lots of drives in this machine. And here comes our motherboard. The motherboard is surprisingly clean compared to the rest of the machine, so no need to wash this board. We'll have a closer look at the board in a minute. I think I just found the reason to why this case is so incredibly heavy, even now that it's empty. Check this out. Back here, there's this huge die-cast piece of metal. This thing is really heavy. What an odd design choice. Why the heck did I make this massive bracket? Now, if I'm not mistaken, the screw that I found inside the machine should fit here, and it does. Okay, so now this bracket is complete. Screws and things like this can sometimes be really tough to find for these PS2s. This panel badly needs a wash, so we need to remove that speaker. It seems to be held in place with 2 tabs here. Oh, I see, there's a 3rd tab here. So not an easy speaker to remove. Oh, actually it wasn't all that difficult. Okay, so now I can wash this panel. And this absolutely disgusting power switch. Yuck. The most common fault with IBM PS2s is of course the diskette drive. Strangely enough, this drive is the only thing in this machine that is not installed with the typical IBM bolt head screws. So I'm guessing it was supplied with this bracket from Sony. Okay, no leaky caps on this PCB. So maybe this is an exception. Wow, that is a really clean drive. But what's up with this bracket here? Yeah, this bracket here looks bent. I haven't worked on one of these drives for quite a while. But I don't remember this bracket being bent up like this. We better take a look inside this drive right away. So I'll disconnect all the connectors from the PCB underneath. Now we can remove the screws holding this PCB down. Now let's see if this is an exception and if this is a PS2 drive without leaky caps. Okay, interesting. So no electrolytic SMD caps on this PCB either. Just one regular cap. One tiny dust bunny. So this drive doesn't even need cleaning. That's awesome. I'll put it aside. We'll test it out in a minute. Now, how about that beefy power supply? Place your bets. Are we going to find any refus inside here? Well, it's from 1992, so quite likely. And the usual disclaimer. Please don't mess around inside power supplies. Caps inside here may be charged with mains voltage, even with the cord unplugged. To prevent us from messing around inside these, they have these annoying security screws. Oh, hang on a minute. There is actually something loose inside here. Yep. Well, I'm glad I decided to check. So, what the heck are we going to find inside here? The warranty seal has not been broken. So, no one has been messing around inside here. But that is going to change in a minute. Okay, let's see how this comes apart. Okay, so wow, those dust bunnies are huge and disgusting. So what the heck is rattling around inside here? Oh, I see something down here. It's just a plastic part, similar to the other piece we found earlier. I think this is for the plastic brackets at the back of the case. I'll add it to the collection. This power supply obviously needs a wash. So we need to take those PCBs out. If I can figure this out. And here's one of the reasons why I always check inside the power supply when I restore a vintage PC. And the other reason is, of course, leaky caps and nasty little reefers, but I can't see anything leaking or bulging inside here. These safety caps seems to be some other brand too. So this power supply just need a bath. Okay, everything has been washed or dry cleaned, so this machine should be much nicer to work on now. And apparently this is a late Model 57 SLC board. You can tell because earlier boards have tons of bodge wires in this area. So we've got onboard SCSI, and these boards will take up to 16 megs of RAM on the motherboard. Strangely enough in 3 sockets. We've got an empty Matco socket, and under this strange looking heatsink we've got the IBM SLC that is supposedly 88% faster than a regular 386. I'm not sure I believe IBM marketing, but I'm sure it's at least significantly faster than a regular 386. But we always want more, don't we? So I picked up this guy here, and this is an interposer that I think will work in this machine. It's an IBM 486 SLC2. It's a pretty simple board. We've got the SLC down here, a voltage regulator, a logic chip, and an empty socket for Matco. But unfortunately, there is a problem with this board. Check this out. Just look at this mess. I don't know what the story is behind this interposer. It was given to me for free years ago, but I suspect it has been thrown around at e-wastes. There's some kind of crap here. Can't quite tell what it is. Let me check with some magnification. Oh, these are actually pieces of wood. So how the heck did they end up on an IBM interposer? The CPU has seen better days too. I think this board has been thrown. And it probably landed on this side of the CPU. So the pins on all 4 sides are bent. But I did an inspection and I can't see any of the pins being broken off. So if we're lucky, the CPU doesn't need any fixing. There's actually a mark here, so I guess this is where it landed. So this contraption here looks like it could be 2 sockets stacked on top of each other. And someone has tried to pry this blue socket off. But by the looks of it, it didn't work. So these are not 2 separate sockets. They seem to be 1 socket with very long legs. So unfortunately we can't just pry this piece off and replace it. But let's see what can be done. On this side of the board we've got tons and tons of solder pads. But the pins from the socket are not coming through here. So these pins here must be very short. Let's find out. This is a really cool interposer. So I hope we can save it. Well, that didn't work too well. Let's first add some fresh solder. And then try again. Yeah, that worked a lot better. So the pin here sits flush to the PCB on this side of the board. So this shouldn't be too difficult to remove. But it's a lot of pins. I guess I'll start with 1 row and see how this goes. Adding fresh solder makes it so much easier to desolder something. Yeah, this is totally working. So I'll go ahead and clear out the remaining through holes with the same method. The SLC on the motherboard has 8K of cache and it's running at 20 MHz. The SLC2 on this interposer is clock doubled and it has 16K of level 1 cache. So this interposer should give a significant speed boost. Let's hope we can save it. By the way, we could try to straighten those pins up. But unfortunately several of the pins are broken off and missing. Some of them might be extra ground pins. So the interposer might not need all of the pins. But I think I have a better fix for this anyways. I noticed that some of the through holes here don't have any pins. So we need to remember to skip them later. Well, that took some patience. But now all the through holes are cleared out. But we can't just pull that socket out. If we do, we will most likely rip some of the pads off the board. So instead, I installed it in a PCB holder. Now I'm going to use some hot air to see if I can get all those pins unstuck. Since the pins are so short, I can't really feel if they're loose or not. But I'm gonna have to assume that some of these pads are still stuck. I have never removed a socket quite this large, but I imagine this is going to take a while. So I'll be heating these pads up and skip ahead. And if we're lucky, the socket will just fall out and not require any force. Now the rework station set to 350. I hope that's enough. I don't want to risk warping the board. No, this is taking too long. And we're risking warping the board. I skipped ahead here. But this is taking a lot longer than I'm comfortable with heating up a small PCB like this. So this is what I think we'll do. I'll grab my Dremel and I'm going to cut through the socket here. And then we can remove one small piece at a time. This is going to get really messy, so I'm going to have to step outside for this. Maybe not. I think this is too risky too, because if I cut too deep, I will make an incredible mess of that board, and it's going to be really tough to repair. Okay, let's try something else. So I have taped down one thermocoupler on each side of the PCB and installed it in the PCB holder. This socket is so thick, so I don't think the heat will go through the socket and heat the PCB up underneath. So I installed it upside down, and then we're gonna have to turn it around somehow. Let's turn the heat on, and I'll heat the board up to 130 degrees Celsius. I still haven't replaced that extremely annoying fan in the preheater. So thermocoupler B is underneath the board, and I'm gonna wait for it to reach 130 degrees. And then we'll flip that PCB upside down and see if we can get that beefy socket off. Okay, the board reached 130 degrees, so I flipped the PCB the other way around. I removed the nozzle from the rework station. Now let's heat up these pads. See if we can get that stubborn socket off. And here it dropped. Finally. I'll turn the temperature down to 50 degrees and let it cool down. And here's our stubborn little socket. Okay, so here's what I'm thinking. If we take male and female pin headers and put them together like this, I think we should have roughly the same height as the original socket. Wow, that was lucky. I'd say that's pretty much exactly the same height. It's hard to tell because these guys are so bent up. But it's definitely close enough to be able to solder the pin headers straight. I'm gonna install the female pin headers on the original sockets. This first row here is one pin header shorter than the other ones. With all the female pin headers installed, we have basically just made that socket slightly thicker. And I think it's needed because we've got some VRAM close to the socket here. And our interposer needs to go above these chips here. And now we can go ahead and install male pin headers on top of those female pin headers. I made this first row one pin shorter. The original socket had 3 empty pads on the 5th row. These interposers came with a plastic bracket like this to make it more sturdy. I don't think it's absolutely necessary, and it installs through these holes here at the back of the board. And then the interposer will snap into position here and be a bit more stable. Okay, let's see if the board fits the homemade socket. Oh, it did. And surprisingly easily. I'll push the board down at the back here. And it snaps into place. And it's held down with a plastic bracket at the back. I was expecting to struggle quite a bit to align the board here, but apparently the pin headers here are perfectly aligned. That was luck more than anything. Oh crap. The cap had fallen off my flux pen. It has completely dried up. This was my last pen. I have not ordered a new one. Well, I guess we can just use some regular flux and just smear it. But it does get really messy compared to the flux pen on a nice and clean board like this. A flux pen is more than sufficient and so much easier to clean. With the board installed in the new socket, it sits perfectly flush. I'll solder just 2 of the pins and make sure. Yep, perfectly flush. By the way, I checked and we didn't warp the board. Thanks to the preheater. And if you don't have a preheater, cheap heat gun would have done the job too. I'll solder all the pins and skip ahead here. Wow, that took a while, but now it's done. But I need to take care of that flux mess. And then I think we're ready for a test. Okay, all cleaned up and ready. I'll give the board a proper wash after the video. And here you can clearly see why they had to use that thick socket. The board sits right on top of the VRAM. I washed the power supply in warm soapy water. And it's now very nice and shiny. As good as new. Even that nasty power switch cleaned up. Now looks great. The nice thing about restoring PS2s is that the plastic's rarely yellow. Okay, power supply, keyboard and display connected. Fingers crossed. Let's see if all that soldering fixed that interposer. The fan in the power supply spun up. We've got a cursor and a bunch of errors. And it's posting. Awesome. I think we fixed that interposer. This is looking really good. So we've got 8 megs of RAM. So we need to add 8 more. And a 601 and 161. I think that's the battery and time and date. So that was expected. Sweet! So we saved that interposer. Awesome! I had a look at the drive. And it's definitely damaged. I think someone forced something into this drive. Maybe a diskette incorrectly installed. So this piece here is all bent up. But this looks like it's fixable. So I'll do my best and see if I can get it back to shape. Okay, a few minutes later. It's not perfect. But let's hope the drive isn't too picky. I'm only guessing here. But I think this is how it should be installed. Let's insert a diskette and see how it behaves. Yeah, the diskette is pushing on that bent up tab. So I think maybe someone tried to install diskettes upside down. I don't know, I'm just guessing here. Now let's see if this works. I think it does. Yeah, all the mechanical parts seems to be working. So let's hope for the best. Replacement drives are not easy to find. Made a copy of the reference disk from Ardent. If you're new to PS2 stuff, this is the diskette that will give you access to the BIOS. If the drive works, that is. Fingers crossed. It's counting up the RAM. The motor is spun up and it started to seek. I will still have those expected errors. Oh, it seeks. Yes, it works. Wow, that was lucky. So apparently it wasn't too picky having that bracket perfectly straight. The system may need to have the battery replaced. Yeah, it definitely does. We haven't even installed it yet. So let's install VARDA just for the hell of it. Now look at these guys. Battery experts since 1987. Wow, that is hilarious. VARDA batteries from 1987 are leaking like crazy. This IBM has a Panasonic battery installed. So quite possibly the original battery. So let's install that riser with the battery. I'm going to remove these two 4 meg sticks and install one 8 meg module, because I don't know yet if it's compatible, so I want to test it out. Let's power the machine up. Okay, let's hit enter. Pretty sure that was an 8 meg module. I need to double check. That is a very long list of errors. Okay, so now we've got a processor board error. Guess that just means it recognized that CPU board. I'm just gonna set a random date. Automatic configuration complete. Press enter to boot. We'll still have a couple of errors. 201 I think is a RAM error. Memory size error. If you have installed or removed, run automatic configuration. Let's turn that machine off and check that RAM stick. Yeah, it clearly says 8 megs on it, so I'm not sure what's going on here. Let's try the other two. These modules are clearly marked 4 megs, and that's what the system sees. So maybe this RAM stick isn't compatible with this machine. I'll do some tests here and swap them around and see what happens. No, we're just getting 12 megs, but we should have 16. Okay, that's a new error for me. 768K of memory is either needed to configure other system resources or not enabled because they contained previously found defects. Never seen this one before, so maybe we have a bad RAM. Okay, let's see if our luck continues. Let's test that hard drive. By the way, I checked on Ardent, but I couldn't find any part numbers for what SIM modules are compatible. So we're gonna have to do with 8 megs for now. And I guess I'll go through my stash and try a few out. Okay, we got a 164 and 174. And still that memory size error. Automatic configuration is being run and complete. Let's boot. See what happens. I suppose 8 megs of RAM isn't too bad for a machine like this. But I think 16 would be perfect, because I plan to install Windows on this machine. Okay, let's go to set configuration and go to set and view SCSI devices. Okay, we've got a 216 meg drive at address 6. So this is looking good. So let's just save and exit and reboot the machine again. Okay, fingers crossed. Let's see if that drive works. Okay, no errors this time. And it boots. Awesome. And it's running IBM DOS shell. Not a fan, sorry. So let's jump into proper DOS instead. And it's actually running Microsoft MS-DOS 622. And apparently it has Windows installed. Awesome, so we've got a working 200 meg drive. Okay, so all the parts seems to be working. Now let's see if the interposer is still removable after the hack. It's quite tight, but it came out, and all the female pin headers stayed on the board, just as I was hoping, but I wasn't sure it would. So this is looking pretty good. Let's check with SpeedSys and see what it thinks of the CPU. Okay, and SpeedSys thinks it's 386DX 21 MHz. We're getting a score of 5.34. It's barely visible on the scale here. Now let's check that cache. So it should drop at 8, and it does. Let's try Superscape next. This is the version 1.0C for faster PCs. I wouldn't call this machine a fast PC, but as long as we use the same version for both tests, it doesn't really matter. Okay, almost done. Let's see how slow it is. 10.4. Yeah, that sure is slow. Okay, great. So now we have something for comparison. Now the question is, of course, is the interposer still reinstallable after we have removed it? Oh, it is. That actually went in without any problems at all. That was easy. So that was actually a really good way of replacing that socket. It works perfectly. And IBM still posts. And it boots. So everything is working perfectly. We'll run some more benchmarks in a minute and see how much faster this PS2 is. But first, let's put that motherboard back into its case. I think someone has deliberately messed up this front panel, because I think these two tabs here, they have been bent down. And it's not apparent why, but maybe they use some unusual drive, because a regular CD-ROM drive will fit here without issues. While bending these tabs, this part in the middle here has been completely bent out of shape. So that's why it looks so messed up in the front. So I'm gonna try to bend them back up again. Yeah, they seem to be soft enough to bend back. I think these tabs are meant to lock the drive. Okay, that actually took a while, but I think I got it reasonably straight. But it wasn't as easy as I thought. And indeed, I think these tabs here are designed to lock the drives. So maybe someone was using non-standard drive rails that were just too long. That could also be a problem for me. But in that case, I'll chop the rails off and keep the tabs original, because these are printed rails and not hard to find original parts. Okay, let's put that lid back on and see if it looks any better. Yes, definitely much better. So now the front doesn't look all messed up anymore. With the front panel back on, it's quite obvious that these tabs are aligned with the rails here. With the cover underneath cleaned up, it doesn't look too bad. Standing up as a tower. Unfortunately, I don't have matching replacement feet for this machine, so I'm just going to use these generic 3M rubber feet. It's not going to look good, but it's better than nothing until I can find matching feet. Well, it looks pretty good standing up as a tower, but I think I prefer it as a desktop. Okay, let's see what SpeedSys will make of that SLC2. Apparently it thinks it's 486SX running at 40 MHz. We've got a massively improved score of 11.72. Let's see if the cache will drop at 16 here. And it does. So twice the cache and twice the speed. And 486 instructions. That is quite a bloody improvement with a simple interposer. Okay, let's run Superscape. And again, this is version 1.0C for faster PCs. And we got 10.4 with the original CPU. Now let's see how much of an improvement this is. Okay, almost done. Let's see what we will get. 16.5. Wow, that is about 60% faster. Not a bad upgrade. So that socket was totally worth replacing. Well, we're not done yet. This machine clearly needs a CD-ROM here. More RAM, a sound card and Windows. Oh, I almost forgot, we also need to glue that lid, but I need to find the matching screws first. Otherwise I won't be able to align the screw holes while I glue the tabs. I'll see what I can find in my stash and order the rest. When the next video is done about this PS2, I'll put a link on the screen here. Meanwhile, check out this video. I'll end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching, I'll see you next week.